Hi everyone, welcome back to my YouTube channel Tech Data Engineer. So in this video, I'll discuss Spark memory management. Okay, and the topic related to Spark memory management, like what is executor memory, where Spark memory lives. Apart from that, how executor memory splits. Like that is the core concept, like how execution memory and what is the difference between storage memory and execution memory, how a Spark shares memory. Okay, that is very important to understand the your actual you can say processing of your job, Spark job. Then we will understand like what is the memory pressure, what is the common OOM issue, like a real production case, like how in what scenario driver kills, and what is the issue with large broadcast variables and all. Okay, so let us start with the our first things, memory management. Okay, so I'll start with the memory management first, Spark memory management. Okay, okay. So let's start with the Spark memory management. Okay, so in a Spark memory management, we have the executor memory. Okay, we have the executor memory. Okay, so first we will understand the what is executor memory and all. Okay, so what is executor memory basically? So let us understand with the real time analogy. Then we will understand what is executor memory and all. Okay, so first understand with the executor memory analogy. Okay, so let us consider executor is like a factory. Okay, we have a factory. Under factory we have worker inside the factory. So factory is a executor and worker inside factory is a task. Okay, so whatever the task we are processing in PySpark, that is like a worker under the factory who like which are the worker inside factory is the same analogy for the task, and the raw material and the temporary tool whatever we are using, that is the memory. Okay, so if anything happens, any disruptions happen, so if it is not managed well, what will happen? Factory crashes. So if in our case, if memory is not managed well, what will happen? Out of memory issue will happen. Okay. So let us understand with the executor. So executor memory is nothing but it is a each executor is a JBM process. Okay. So each each executor executor is a JVM process. Okay, so each executor is a JVM process and that has a fixed amount of memory. So executor have fixed memory. Okay, that has a fixed memory. So suppose in our case I'll consider is a 8 GB is the our fixed memory. Okay, so this 8 GB is not only used for one thing. So what will happen? A Spark. So a Spark basically divides this 8 GB memory, 8 GB memory. Okay, so this Spark basically divides 8 GB memory. Okay, so what is this executor is a JPM process with a fixed amount of memory. Okay, and a Spark, so this is not only the case where 8 GB is not only used for only one thing, either only for executions or storage. It is getting swapped whenever it is required. Okay, so Spark divide it into different parts. Okay. So now let us understand what are the main component under the like high level memory split. Okay. So we will understand simple view. Okay. So if you'll see high level memory split here, high level memory split. If you'll see here, so we have the executor memory. Okay. And this memory have like we have one is the Spark managed. Spark managed. Okay, it is approximately 60%. Okay, that 60 percentage approximately 0.6 fraction is managed by this. So Spark managed memory basically. So Spark managed memory, it has two things. One is for execution memory, and other is for storage memory. Okay, so we understand what the executor is. Executor is a JVM process, and that has a fixed memory. Suppose that has a fixed memory of 8 GB. Now Spark divides 8 GB of memory. So if you'll understand high level of memory management, so executor memory have the Spark managed memory that has the execution memory, storage memory. Apart from that, we have the like user memory, or we have the reserved memory. Okay, reserved memory. Okay, we have. So we can, so but in this topic, we are only concerned about the Spark managed memory. Okay, because out of memory mostly happen here only. Okay, so we are not interested about user memory. We are not interested about the reserve memory. We are only interested about the Spark managed memory. So in case of a Spark managed memory only, out of memory issue happen, and that only we need to understand. Okay, so let us understand a Spark managed memory. Okay, it has two things. One is the execution execution memory, and other is the we have a storage memory. Okay, so we need to understand Spark managed memory is shared by two types of work. Okay, one is the execution and one is the storage. Okay, so there are two things. Okay, so what is execution memory? First we will understand what is execution memory. Okay, so memory used while doing calculation. So this is basically, so execution memories. So these are the memory used while doing calculation. Okay. So whatever the calculation in your job, if it is using, that is called execution memory. So what are the example? We have the join, we have the group by. Okay. We have then we have join, group by. We have aggregation. We have short, like window function, shuffle operation, shuffle operation. Okay, so these are the examples where we are using memory used while doing calculation. That is called execution memory. Okay, so execution memory is like a working table. Okay, so like I'll give the example also, but for now we will understand. These are the case where execution memory is getting used. Okay. Now second we have the storage memory. Okay, storage memory. Okay, so storage memory, store and reuse memory. That is basically store and and reuse. Okay, store and reuse memory. Okay, so what is it? What is store and reuse memory? So that is basically memory used for store data for later use. Okay, so memory used to store data later use for later use. Okay, so that is called storage memory. So a storage memory, what are the example we have? We have the cache, we have persist, we have broadcast table. These are the example where we are using this. Okay, so cache, persist, broadcast table, these are the example where we are using this one. Okay, Now, um, so a storage memory is like a warehouse. You store the item, you reuse them multiple times. Okay, they stay until removed or evicted. Okay, so there are two scenarios: one for storage, one for execution memory, one for storage memory. We'll understand. So executor have two types of memory. One is the storage, one is the execution. Okay, so now we need to understand why Spark is smart. Okay, why Spark is smart. Okay, so Spark does not fix memory size. Okay, the issue is that is called unified memory. Unified memory. So Spark basically does not fix the memory size strictly. Okay, so Spark does not fix memory size strictly. So instead, what it uses the unified memory. So what is mean by unified memory? So unified memory is, so execution memory and storage memory share the same pool. So that is the same memory pool. Okay, that is shared by, that is shared by execution memory, that is shared by execution memory as well as storage memory. Okay, so this is the memory pool that is shared by both of them. Okay, so if execution need more memory, what will, suppose these are the half things. So if execution needed more memory, it is reshuffle from here. Okay, it vacate from here. If execution, so if execution need more memory, Spark can kick out the cache data. Okay, so if execution need data, what it will happen? It will go, it will kick out the storage data. Okay, so if storage need more data, what will happen? Execution give back when free. So whenever this memory get free, it give back to the storage. Okay. So execution have more priority. So if this execution memory is not there, and and because of some reason, some our different actions or transformation, if a storage memory is filled by this memory pool, then out of memory issue happen. Okay. So we have seen that why out of memory happens. So if our storage memory is less, storage memory is filled by this execution pool, this memory pool, and if we require the execution memory that is not sufficient to fulfill our requirement, then that is called out of memory issue. Okay. So in factory case, we understand one room, big room is shared by workers and storage cells also. So where we will give the more priority, we'll give more priority to the workers. We can keep the storage things outside also, but we can't keep the worker outside and the storage inside. So we will think like this analogy. Okay. So now let us understand why out of memory happens. Okay, happens. Okay, why out of memory happens? So for now we understand what is executor memory, what fraction memory is managed by Spark. So a Spark managed memory is divided into two types. One is the executor memory, one is the storage memory. Okay, so out of memory happens when, uh, first scenario, when a task need more memory. First scenario, when why out of memory happens, a task need more memory. The second scenario, so Spark cannot free enough space, enough space. Third scenario, JVM crash. So these are the three scenario where out of memory happen. Okay, so let us understand each scenario in details. Like a task need more memory, Spark cannot free enough space, and the third is the JVM. Okay, so first we will understand. Okay, first we will understand collect scenario. Okay, so if we are performing the collect, what will happen? It's basically a driver killer. Okay, driver killer, driver memory killer. Okay, so suppose we are writing def dot collect. Okay, so what will happen if you are writing that? So, so what will happen? So what Spark does, read all the partitions. Okay, so if you are doing the df dot select, what will happen? It will read all partitions. Okay, it will read all partitions, and then it will send all data to driver. Okay. Okay, so these two things will happen. So then driver tries to keep everything in the memory. So it will read all the partitions. If you are doing df dot collect, I'm telling the collect scenario. So if you am doing df dot collect, so read all the partitions, then send all the data to the driver. And then third scenario, what will happen? Driver tries to keep everything in the memory. So driver tries to tries to keep everything in the memory. Okay, so then what is the result? Then driver have then this is the case of driver out of memory issue. Okay, then this will happen. Okay, so here there is nothing to do with the executor memory. Okay, executor memory. That is the issue with driver. So here driver got killed. So this has nothing to do with the executor memory. Even if executor have, so now we need to. So if you are doing the actual real-time production things, so now so suppose this issue will happen and someone will increasing the executor memory from 50 GB to 100 GB. Okay, 100 GB. Okay. So here nothing to do with the executor memory. If we are increasing the executor memory also, that issue is still persist. Okay, this issue still persists. So what we have to do? We don't have to do we don't have to increase the executor memory because this is the issue with the driver. Okay. So what is the safer approach we have? Okay. What is the safer approach? What solution we can provide? So safer approach should be 1 minute. Okay, so safer approach should be df dot always use df dot show. Okay, df dot show method always use. Okay, or you can use df dot take. Okay, there you can pass something like 100, or you can use df dot limit limit 1000 dot collect. So if we are using these three things, then our this issue will not exist. Okay, so never use. So what we understand here, the important thing, what we understand here, important thing, never use never use collect on big data. Okay, this is the things we understand. Okay, now let us understand the second thing, the second point, which is the issue, larger broadcast. Okay, okay, larger broadcast. Okay, larger broadcast basically executor memory issue. Executor memory issue. Okay, so if so, first we will understand what is the broadcast join here. Okay, so if we are doing larger df dot join broadcast then we are passing the small df. Okay, suppose on id I'm passing something like this. Okay, so what a Spark does, copy a small df. So basically what a Spark does here, so it is copies a small df. Okay, copy small df, send it to every executor. Okay, send it to every executor. Okay, and third things what it will do, store it in storage memory. Okay, so store it in storage memory. Okay, this do the three things: copy the small df, send it to every executor, and store into a storage memory. Okay, so what is the problem? So problem is, so what is the problem here? So if a small df is actually large, okay, so suppose broadcast size we have like 200 MB, okay, and executor is 20. So memory used how much? 200 into 20. It equals to 200 MB into 20 equals to 4 GB approximately. Okay. So that is the executor. That is basically the executor out of memory. Executor out of memory. Okay. So what we understand here, we understand do not broadcast the last table. Okay. Do not broadcast large table. Okay. So and disable this auto broadcast feature also. Disable auto broadcast if needed. Okay. Okay. So the one benefit we have like broadcast saves supples, it save shuffle operation. Okay. It saves shuffle operation, but what it do? It saves shuffle operation. What it do? But consumes more memory. Okay, that is the issue it has. Okay, so we understand larger broadcast like that is the executor memory issue. So if we are using larger broadcast things also, then that is also the one of the reason for out of memory. Okay. Now third things we understand insufficient partitions. Okay. Okay. So third we are understanding insufficient partitions. Okay. Insufficient partition. Okay. So one partition equals to one task. Okay. One task, one task uses memory. Okay. So suppose we have like df dot repartition and then we're passing two. Okay. So what happened here? Only two tasks. Okay. Only two tasks. Each task processing huge data. Suppose and then each task is processing huge data. Okay. Huge data we have. Huge data. Okay. Need so then what will happen? It required the larger execution memory. Okay. So here it required the larger need larger execution memory. Okay. So that is the bad example. That is the bad example. Okay. Now we will see the good example here. What is the good case? Good example. Okay. So good example is like df dot repartition. We are passing the 200. So what will happen? These are the 200 small tasks. Each task uses less memory. Okay. Each uses less memory and easier to fit in the executor memory, and that is easier to fit in executor memory also. So in above case there's only two tasks, okay, but that is required larger memory because we have the less partitions. Okay, so one big suitcase is harder to lift than many small things. Okay, so that analogy we understand here. Like one thing, if we have only the less partitions, then we require the higher executor memory. And if that is not the higher executor memory, and if our executor memory is not that much sufficient, or it is not available, then it will give the out of memory issue. Okay, we understand these things. Now we will see the other things, the next thing. So here I'm explaining the scenario where out of memory issue will happen. Okay, okay. Now will understand. So there is one scenario called data skewness. Okay, data skewness. Okay, so what is skew? So skew, what is skew basically here? So skew is one key has huge data and others very small. Okay, others very small. Okay. So suppose we'll understand, like we are we have the country wise data. Okay, country. So US have 80% and others have 20%. Okay, so if data has these types of scenario, so what will happen? Only task process massive data. So here only one task process massive data. Okay, so only one task will process massive data, and one task will process massive data. So if one task will process massive data, what will happen? So that executor runs out of memory issue. Okay, so data skewness is one of the reason. Okay, so that case will have what happen? Job stuck or fail. Okay, so these are the scenario will happen. So, and these things so in this scenario, one task run forever, and then a small same executor fails repeatedly. Okay, so that is the issue with that. So, what is the fix in case of skewness? So, fix we have either use uh, key salting, key salting, or use broadcast join, or use enable. You can use enable AQE also. Okay, we already know what is AQE. Okay, so these are the three things we need to do, or we can use like adaptive enable, like a spark dot SQL dot adaptive enable adaptive enable equals to true. Okay, so the issue is like if we have uneven data, we have the uneven memory distribution also, uneven memory uses also. Okay, so that is the issue we have. Okay, so now the final things we will understand in which scenario what will also happen, like execution versus storage. Okay, storage. Okay, so if you group by out of memory, then what will happen here? It is using execution memory. Okay, if we have the join out of memory issue happen, what is the problem is the execution memory. If there is a cache too long, too big, then what will happen? Then it is a issue with the storage memory. If that is the broadcast too big, then that is the issue with the storage memory again. Okay, if collect we are performing, then that is the driver memory. Okay, basically driver memory. So we understand what in which scenario issue with the execution memory, which scenario issue with the storage memory. Okay. So like then we need to understand why memory tuning is alone is not enough. Okay. So what is the wrong thinking? So increasing every time executor memory is not the solution. Okay. We understand initially, right? Because there is issue the driver memory and we are increasing the executor memory, so that is not the solution. So every time increasing the, so wrong thinking is, what is the wrong thinking? Wrong approach. Wrong approach. Not always, not always increase executor memory. Okay, that is the wrong approach. So correct thinking, task process partitions. Okay, so what is the correct thinking here? Correct approach is correct. What is the correct approach? What is the correct approach? So correct approach is like task process partitions. Okay, task process partitions. Then partition size, decide memory. Okay, then we have the partition size, decide memory. Then memory. So here memory plus partition tuned together. So if we are following this approach, then we will solve most of the productions out of memory issue. Okay. So we will understand with example also. Like we have suppose 8 GB of executor. Okay, executor. So one huge executor out of memory. So same 8 GB plus 200 other if partitions, that works fine. Okay, that works fine. Okay. So golden, what is the golden line? We have partition size control per task memory uses. Okay, so partition size controls per task memory. Okay, so this is the things we need to understand. Okay, here. Okay, this is the things we need to understand basically here. So now the final thing, how to debug the Spark memory basically. Okay, so so how to debug this? Okay, so what is the debug process? Okay, debug. So first we need to see the executor tab. Okay, then we need to see storage tab. Then we need to see storage tab for data set. Then we need to see the SQL tab basically for join and all. Okay. So if you are following this approach, definitely you will solve your problem. Okay. So basically, Spark memory is mainly divided into execution memory, that is for temporary computations like join and aggregation, and a storage memory for cache data and broadcast variables. So out of memory issue commonly occurs due to collect large broadcast, insufficient partitions, skew data. So memory tuning must always be done together with partitions tuning, and because partition size decide how much memory each task need. Okay, so that is the, so if you wanted to summarize basically, so if you wanted to summarize here what we can do, so so if you wanted to summarize basically what we can do, we can just think like that is the, so we can think like, so we have executor memory suppose. executor memory, and that is 8 GB. Okay, so here we have the Spark managed memory. Spark managed memory, that is nearly the 60%. Okay, and it has two things. One is the executor memory, another is the storage. One is the storage memory. Okay, and then other we have like uh, user user memory, and we have like reserved memory. Okay, so these are the basically executor memory. We have a Spark managed memory and executor memory and storage memory. So out of memory will issue will happen only here. Okay, out of memory. So if we are not managing the thing correctly, if we are not managing, so the solution we what is the solutions we have? So we can Spark execution memory is mainly divided into execution memory and that is storage memory. So execution memory is only for temporary computations like join and aggregation, and storage memory for cache data and broadcast variable. So out of memory issue commonly occurs due to collect, large broadcast, insufficient partitions, SQ data. So I have already explained what is the issue with collect, large broadcast, insufficient partitions or SQ data, and what is the solution also for that. Okay, so these are the things if we'll understand better way we will debug the production job. Okay, thank you, thanks for watching.